41, 42, 43, 44, 45, 46, 47, 48, 49, 50.
Hey everybody, welcome to week 4 of PS 231. Time is flying. I know maybe it's not flying as much for you as it is for me, but you know we've covered a lot of ground already, and it's time for us to start talking about some real strategic game theoretic sort of stuff today. We'll finally be talking about multiple people, right? So in the previous lectures, rationality, choice under uncertainty, we've talked about one decision maker in isolation, right? So we've said, imagine that somebody goes into a mini mart. And then in week 2, we said, and imagine that they're looking at the beverage aisle and they're trying to figure out which of the alternatives in the beverage cooler they like the best. And then we talked about different ways that you might model that. We had 3 fables that would tell you how you might model that particular decision by one decision maker in isolation, one person standing in a mini mart, dazzled by the choices, saying to themselves, well, how do I feel about this? And then we extended that model for what happens when they're done at the beverage cooler and they go over to the counter and decide which lottery ticket to buy. So week 3 was choice under uncertainty. Again, we had one decision maker behaving in isolation. We studied them in a vacuum. We said, well, this is a trickier problem. The problem of preferences over lotteries is a little bit trickier. It's also a little bit richer. There's more to work with the structure of all lotteries. So we imposed some more assumptions, we got a stronger result. Now we have this delightful expected utility function that allows us to model individuals, where that might mean individuals like humans, or it might mean agents in a bigger sense. It might mean a state or a group or a political party or whatever the case may be. So we've talked about how to model one decision-making unit, be a human being or something a little bit more disaggregated, in isolation. Now, there isn't a whole lot of strategy involved with that. There isn't a whole lot of strategic problem involved in that. It's been one decision maker in isolation. And so what makes a class in strategic models a class in strategic models is what happens after. So all rational choice theory begins from the same set of fables that you've just learned, right? They all begin with individual level rationality. But then how social processes play out given these individual assumptions, that differs depending on what sort of formal theory you're living within, right? So if I'm a microeconomic theorist, then I might say, okay, here's all these individual agents that are responding rationally, and they aggregate their preferences in markets. In game theory, we're going to say that they aggregate their preferences through strategic interaction. And to dip our toe into that water, I want us to talk about sort of a foundational strategic problem and a foundational normative concept that allows us to link that this normative concept will link pretty intimately into the strategic problem in question. So, not to obfuscate things, the strategic problem, and it's a problem that we're going to see again and again and again, is the strategic problem of bargaining. Even as we speak, my wife is at a car dealer today. It's Labor Day, and there might be some sales going on. So even as we speak, my wife is at a car dealer, potentially engaged in bargaining. We see bargaining all the time. We see bargaining at car dealerships. We see bargaining when you buy homes or when you buy other sort of, you don't bargain when you buy a Diet Coke, but there are some things that you buy that involve some amount of bargaining. But we also see bargaining in political processes. So in legislatures, we see bargaining between different parties. In international relations, we see bargaining in the crises that occur before a dispute escalates to war. Within domestic institutions, we see bargaining between leaders and opposition groups. So we see bargaining all the time, and this raises an important question. What makes bargaining bargaining? What is bargaining? How would you encode bargaining? How would you say, this is what makes bargaining bargaining? You can pause the video if you need to, okay? You might need to say to yourself, hey, what makes bargaining bargaining? I'm going to give you a pretty simple answer in terms of how game theory thinks about bargaining. But there's all sorts of, It's a very simple answer, and what you have in mind might be something broader. So reflect on that for a moment before you continue too much into the video. What is bargaining, and what makes bargaining bargaining? How would you know bargaining when you saw it? How would you know bargaining with respect to other processes that might be at work? It's a tough question, right? And the normative thing that I want to talk about today, normative might be a slightly strong word, but the should be part of today's lecture is going to be the Pareto efficiency criterion, sometimes called Pareto optimality criterion, both of which are named after the Italian economist Vilfredo Pareto. What makes an outcome efficient among various actors? What makes it, in a sense, optimal? Now, we're not going to issue very many criteria of that form in this class. And Pareto optimality actually might be about as far as we go from a normative sense, at least in terms of formal criteria. At random intervals, I might just start shouting, I think this is a repugnant outcome, but I won't invoke any criterion other than Pareto optimality along the way. I might just say this annoys me on a personal level, but that's a different story. So here I'm going to issue a formal criterion for what constitutes not a good outcome, because there are going to be very non-good outcomes that are also Pareto optimal. But what makes a not completely awful outcome? I actually only want to proceed in two parts today. I want to get you thinking about multiple actors, and I can't think of a better way for you to think about multiple actors interacting strategically. I think the best way to get yourself started with that is to think about bargaining and Pareto optimality, both of which have there's some intimate links between these two things too. So before we finally write down our first game theoretic models next week, I just want us to say to ourselves, hey, what do multiple decision makers look like when they're in the same room together? What happens if I have two doodles, two reflexive, complete, and transitive human beings who are deciding what to do together? It's finally time for us to get social here. So in the A block, I want to talk about Pareto optimality. I want to introduce you with the basic criteria, the basic idea about what this normative criterion is. It's going to come up a few times for the rest of the class, and so it's nice to have a moment just to talk about it. And then in the B block, I want to talk about what makes bargaining bargaining. I really want you to get a picture in your mind about what a bargaining process looks like. I want to issue two informal criteria for what makes bargaining bargaining, and I want to show you what it looks like in a physical sense. And then throughout the class, we'll talk about linkages between the two things. You'll be able to see that Pareto optimality is a nice, that features in our study of bargaining, and our study of bargaining will also influence Pareto optimality. And so there's going to be some interesting ideas at work here. I don't want to say it's two sides of the same coin, but it's something very similar to that. So I hope that today's lecture begins to whet your appetite in terms of how we're going to aggregate individuals into something more interesting, more social, more strategic. Let's get started. So here in the A block, I want to talk about this important concept of Pareto efficiency, Pareto optimality. When sometimes people don't even mention the Pareto name, they'll just say efficient or optimal, and they'll proceed as if you know what they're talking about, which is kind of a jerk thing for them to do, but hey, if you can save a word, that's good too. This is a concept, this idea of Pareto efficiency or optimality. I'm probably just going to say optimality throughout today. This concept of optimality is really important. It's a good starting way to evaluate a given outcome. So we're interested in what sort of outcomes emerge from social processes, in particular from strategic social processes. And this optimality criterion is one nice first cut to get a sense about sort of the normative properties of any given outcome. In order for me to introduce this concept to you, I'm going to need to grab something off of the bookshelf of awesomeness, so I'll be right back. I'm gonna get comfy. I'm gonna be here for a while. So what do I have here? I have 3 bowls. This is the Mr. Rogers game is strong today. I need to put some idyllic flute, like, oh. That was the best thing about Mr. Rogers, was the music. All right. So I have 3 bowls. One of them is labeled Chewy. And you'll notice that it's empty. I have another bowl labeled You. And it's empty. And I have a third bowl labeled Total. And it has, I don't want to tip them over, it has 100 pennies in it. 100 meticulously counted pennies. It took some time. Counting is not really a strong suit of mine. So, but I'm pretty sure there's 100 pennies in this bowl labeled Total. And what's the idea? Well, the idea is that I am about to act as what's called a social planner. I'm somebody that doesn't have a utility function. I'm just somebody whose job it is. I'm some benevolent leader. And it's my job as a benevolent leader to figure out how to divvy up this money between you and Chewy. All right? So I need to take some of the pennies from this bowl and I need to put them into your bowls. All right? So there's a lot of ways I could do it. Let's just think about all the possibilities. Before we get started, let's just get the set down first. What are my possible ways of putting these pennies into your bowls? What are the possible distributions, right? And you're like, could you just put the pennies in the bowl? But let's just think about it for a second, okay? So either of you can get 0 pennies. I can give one of you nothing. Right now you have nothing. You have nothing right now. So that's a possibility. It must be, because here it is, right? So you could get no pennies. Yeah? I could give you 1 penny. Let me make sure the sound effects are good. I could give you 1 penny. I could give you 2 pennies. I could give you 3 pennies. I could give you 4 pennies. However many this is. I could give you all the pennies. Okay? So the set of things that you could get is 0, 1, 2, 3, ... 100. Okay, that's the number of pennies that you might end up with. 0, 1, 2, 3, ... 100. And the same for Chewy, right? I could give Chewy 1 penny. That's his allowance anyway. I could give him 2 pennies. I could give him 3 pennies. I could give him however many this is. Or I could give him all the pennies too. Okay? So Chewy could get 0 pennies, 1 pennies, 2 pennies, ... 100 pennies. As of right now though, you both have 0 pennies. The set of all possible ways for me to divvy this though, I can't give you 100 pennies and Chewy 100 pennies. I only have 100 pennies, right? So I can't give away more pennies than I have. This is all the pennies that I have. There's a reason that professors complain about their pay. This is all the pennies that I have in my life, okay? I don't have any more pennies to give, so I can't give you 100 pennies and Chewy 100 pennies, right? It has to be that the number of pennies that I give out has to be less than or equal to 100, right? So for example, I could give you 3 pennies, and I could give Chewy 5 pennies, and so 3 pennies for you and 5 pennies for Chewy, that adds up to less than 100, so we're good. Okay, so I need an ordered pair. I need a vector. I need an ordered pair that says the first number is how many pennies you got, and the second is how many pennies Chewy got. So I need an ordered pair, 2 numbers, 2 integers between 0 and 100, where the sum of the integers can't be more than 100. All right? It's kind of like probability. It's not allowed to add up to more than 1. So we can array that. Let's just look at that. Let's look at that in terms of dots. Okay, so one possibility, let's just plot the number of pennies that you get on the horizontal axis. Okay? And let's plot the number of pennies that Chewy gets on the vertical axis. All right? So now I've got two-dimensional space where the first dimension is how many pennies you get, and the second dimension is how many pennies Chewie gets. And then, just to be completely explicit about it, the possibility where you both have 0, the world where neither of you has a penny, that's the dot right at the origin. That's the dot 0, 0. Yeah? And if I gave you both a penny, I would move to the right one, and I would move up 1, and I'd wind up at the point 1, 1. I couldn't, so there's all these penny combinations. Let me just shout some out and call attention to them as we go. All right, there's the world where you have 20 pennies and Chewie has 15 pennies. There's the world where you have 63 pennies and Chewie has 8 pennies. There's the world where Chewie has 99 pennies and you have 0 pennies. There's the world where Chewie has 50 pennies and you have 50 pennies. There's all these worlds, there's all these possibilities, right? There's all these different ways for me to divvy up these pennies, okay? What we wind up with is this triangle, right? There's the vertical axis, that represents Chewie's inability to get less than 0, so that's one side of the triangle. There's the horizontal, the bottom part, that's our way of saying that you can't get fewer than 0 pennies, right? So we've bounded our triangle because I can't take money away from you as much as I would like to, right? And then we have this hypotenuse part, and that's the frontier. What that represents is the fact that I can't give away more than 100 pennies. So this is my distributional problem as a social planner, is I have 100 pennies to give and a lot of different ways to give them, okay? So that's my problem. Now your problem is you want pennies. So I'm going to assume that both you and Chewie get happier as I give you more pennies. Okay? Which is to say, more pennies, more happiness. That's what sometimes gets called a monotonicity assumption. Monotonicity is just a fancy word of saying it's always going up or it's always going down. Mono, meaning one. So my job is to figure out how to divvy up these pennies. Okay, so suppose that I don't get, and an important thing is the following. Suppose that I don't care how many pennies I keep. I'm the social planner. I'm a benevolent dictator. I'm just handing out pennies, all right? So let's say that I gave you, 25 pennies. And let's say that I gave Chewie 25 pennies. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So right now, you have 25 pennies and Chewie has 25 pennies. Let's mark that dot. All right? Now, notice that the dot that we just marked is very far from the frontier. Right? Now, what does that mean? The fact that we're not on the edge of the triangle. Right? We're not on any of the edges of the triangle. We're inside the triangle of possibilities, right? What does that mean? Well, what that means in a very literal sense is that I left pennies. There are still pennies that haven't been divvied. Undivvied pennies. That's a band name, the Undivvied Pennies. All right? So here's a bunch of pennies. Here's 50 pennies that haven't been divvied. I have left resources on the table. Okay? I could have made somebody happier. I could have created more bliss. But I didn't. I was stingy with my pennies. I only gave you 25 and Chewie 25. Okay? The idea of Pareto optimality is that it rules that out. A Pareto optimal outcome is one where I couldn't make somebody happier without making somebody else sadder. So look, I have resources available to me I have 50 pennies left to give. I could give you a penny. Now you have 26 pennies. I didn't have to make Chewie any sadder for that. You have 26, Chewie has 25. He's just as happy as he was. Right? Heck, I have more pennies to give. Now you're both at 26. But I could still make one of you happier without making the other one sadder, right? So I could give you both. I could give you one. I could give Chewy one. I could give you both another. I could give you both another. So I'm just putting pennies in each. Right now I'm evenly distributing. So I'm going on a little path that starts from that initial 25-25 dot and rides the 45-degree line. It's just riding that 45-degree line from 26 to 27, 27, 27 to 28, 28, 28, 28 to 29, 29, 30, 30, 31, 31, 32, 32, 33, 33, and so on, until I get to the point where you both have 49 pennies. Okay? So you each have 49 pennies right now, and I've got 2 left in my total. I still have 2 pennies left to give. So I could make you both happier without making somebody sadder. Okay? So let me do that. I now have no pennies. We've reached the frontier of the triangle. We took a path. We started at 25-25 and we added 1 to each of you. And that was arbitrary. I could have chosen some other path. I just wanted you to see that eventually we got to the frontier. I just kept adding pennies along the 45-degree line. And then we get to the situation where you both have 50. You have 50 pennies. Chewy has 50 pennies. I have no more to give. All right? There are no resources left on the table. This is a Pareto efficient outcome, a Pareto optimal outcome, because it would be impossible for me to make one of you happier without making another of you sadder. Now look, I can still make one of you happier. So right now it's 50-50, right? I could take 1 away from you and give it to Chewy. Now it's 51-49. Or 49-51. It's 49 for you and 51 for Chewy. Okay? So I've moved on the frontier, but I'm still on the frontier. I'm still on the frontier. I just shifted a little bit on the frontier, right? Okay. What if I took another one from you? Now it's 48 you and 52 Chewy. All right? Now, in order for me to I made Chewy strictly happier. Both times that I gave him a penny, I made him happier because more pennies make him happier. Right? But in order for me to do so, I had to make you sadder. I couldn't make Chewy any better off without making you strictly worse off. So in other words, once we got to the frontier, once we got to that edge, what is that? The northeastern. Once we got to that northeastern edge, it became impossible for me, the social planner, to come up with a way to make somebody happier without making somebody else sadder. The scarcity that I experienced to begin with, I only had so many resources to give out. My total bowl had only 100 pennies in it, okay? So once we got to the frontier, once we exhausted my budget, once there weren't any more pennies for me to give away, right? When we got to that, everywhere on the frontier is Pareto efficient. Everywhere on the frontier is Pareto optimal. Because for any distribution, let's say Chewy has 100 pennies and you have none. Chewy has all these pennies. This is a Pareto efficient outcome. Why do I say that? Well, I wouldn't be able to make you any happier without making Chewy sadder. He's got 100 pennies. I have no pennies to give. If I want to give you a penny, I got to take it out of Chewy's bowl. If I want to give you 2 pennies, I got to take it out of Chewy's bowl. All right? So we get to a certain point where I couldn't make somebody happier without making somebody else sadder. All right? So anywhere inside the triangle, at that 25-25 initial dot, there were opportunities for win-win. If that was the status quo, if the status quo was 25 pennies for you and 25 for Chewy, there existed outcomes where you both could win, where you both benefited. I could make you both happier. I could, right? There were opportunities for everybody to benefit. But once we got to that scarcity frontier, once we got to that northeastern edge of the triangle, it was no longer possible for me to make one of you happier without making somebody else sadder. That's the definition of Pareto optimality. That's what Pareto efficiency means. is we're at a point where nobody could be made happier without making somebody else sadder. Okay? Now, let me just drive home the point that this is a very minimal condition. This is not the end-all be-all in terms of how to evaluate distributions, all right? So, as I just said, the situation where Chewy has 100 and you have 0 is Pareto efficient. Most people, however, would view that as bad. They wouldn't like that outcome. It's Pareto efficient, but it isn't egalitarian, right? Likewise, I could have given you 100 and Chewy 0, and that would still seem a little bit off to many people. They would say, hey, this doesn't seem like a good outcome because somebody has exactly nothing and somebody has exactly everything. That strikes me as wrong on an egalitarian level. Pareto efficiency has nothing to say about equalness or fairness, all right? So when I say this is a minimal condition, I mean this is minimal. Many people have feelings that are deeper than just Pareto efficiency, all right? But consider also that it is possible that you both have a relatively equal number of pennies. So I didn't count them out, but suppose that you both have an equal number of pennies, right? But suppose also that I left some pennies on in the total bowl. Well, if that's the case, then this is no longer Pareto efficient. It's egalitarian, but we wasted. Okay? So we have an outcome that some people wouldn't be so angry about on distributional grounds, but in order to achieve that outcome, maybe we had to pay some costs. Right? We had to leave some options on the table. Now, I can't tell you how to weigh efficiency versus egalitarianism. That's a deeply personal thing, all right? But I do know that Pareto efficiency is one useful criterion to begin a normative analysis for a distribution, right? It isn't the end-all be-all. For some people, it is the end-all be-all, but it's a good start. But don't think that this is a normative panacea. It's just one way to look at the problem, okay? Now, here's another interesting interpretation about what happens at the Pareto Frontier. Sorry, I'm just making sure my bowls are all. So imagine that I've got a Pareto efficient outcome. How do I know it's Pareto efficient? Well, my total bowl is empty. So we're somewhere on that frontier, all right? And so right now, you have many pennies, and Chewy has relatively few, okay? Now, I said to you, at the interior of the triangle, there were opportunities for win-win. There were possibilities that could make you both better off. Both you and Chewy could profit from some other outcome. If you were at 25-25, then I could have gone to 26-25 and made you happier without making Chewy any sadder. I could have gone to 25-26 and made Chewy happier without making you any sadder. Or heck, I even could have gone to 26-26 and made you both happier, right? But on the frontier, there are no such possibilities. The only way that somebody can be made happier is to make somebody else sadder. So every penny that I give to Chewy comes from you. That's what we would call a zero-sum situation. So win-win is the inside of that triangle. Win-win is non-Pareto efficient outcomes, right? Pareto, if an outcome is not Pareto efficient, then there are win-win opportunities. All right? But once we're at that Pareto frontier, the only way for me to stay on that Pareto frontier while adjusting the distribution is to engage in zero-sum thinking. Every penny I take from you goes to Chewy. I'm still on the frontier. So that's actually really powerful, okay? We use zero-sum and win-win in plain language all the time, but this is sort of what it looks like. All right, so how do we encode Pareto efficiency? It's pretty simple. So let's just suppose that there's some set of outcomes, call it X, all right? And let's just suppose for now that we have two decision makers. It's you and Chewy right now. Let's just do you and Chewy right now, okay? So X, that set of outcomes in this example, was the set of all ordered pairs where each number was an integer between 0 and 100 and the numbers added to something less than or equal to 100 because I only had 100 pennies to give. So that's X in this example. And I have two players, you and Chewy. All right? And so how I would say that an outcome, little x, is Pareto efficient is if there doesn't exist some other outcome, call it y, where both of you are at least as good at y as you were with x, which is to say each of you has a utility number from y that's at least as high as it was from x. So everybody is at least indifferent between y and x, and somebody is strictly better off at y than they would have been at x. So we say that an outcome is Pareto efficient if there doesn't exist another outcome that Pareto dominates it. And one outcome Pareto dominates another, one outcome y Pareto dominates another outcome x, if u of y is at least as high as u of x for both of you, and for at least one of you, u of y is strictly higher. Okay? So Pareto domination means one outcome Pareto dominates another outcome if I could make everybody at least as happy at y as they were at x, and at least one person is strictly happier. So going back to the triangle, from any dot that was in the interior of the triangle, I could go up, and that would make Chewy happier while keeping you indifferent. I could go right, and that would make you happier while keeping Chewy indifferent. Or in some instances, I could go both, and that would make you both happier. So Pareto efficiency just means there's a north, or there's an east, or there's even a northeast. But from that Pareto frontier, you can't go to the north or to the east. Going north takes you out of the triangle, going east takes you out of the triangle, going northeast takes you out of the triangle. It's a nice geometric intuition for this. All right? And actually, I won't dig into it, but if you have questions, this is just an interesting truism. And it's related to the philosophy of utilitarianism. Right? So in the 1800s, John Stuart Mill, Jeremy Bentham, among some other English philosophers, were trying to figure out what made an outcome good. This isn't a game theory question. I mean, you can think about a game theoretically, but there's more to it than that. And so these philosophers were trying to figure out what made an outcome good. And utility theory was in its early stages at the time. And so they thought, we should try to come up with the greatest good for the greatest number. This is why it's called utilitarianism. How do we find a way to distribute resources in a way that does the most good for the greatest number? And so I could take your utility and Chewy's utility. I could create, me, the social planner, could say my utility function, my welfare function, is actually just your utility plus Chewy's. And my job is now to maximize the sum of your utilities. My job is to say, Chewy is 50% important and you're 50% important. And my job is to divvy the resources in a way that creates the greatest good for the greatest number. And it turns out that my act of maximizing that welfare function, that is just the sum of every individual's utilities, for any given Pareto efficient outcome, I can find a welfare function that I could have maximized to get it. And any time that I maximize a welfare function, I end up on the Pareto frontier. So actually, my task as a utilitarian social planner, my task as a utilitarian benevolent dictator that's divvying resources, is to maximize the welfare of my citizens. And if I do that, then I will arrive at a Pareto efficient outcome. That's kind of cool, right? So this is an important notion. This is, when somebody starts graduate school, it's one of the first things I would want them to learn in political science is let's think about Pareto efficiency really deeply. But you don't even have to think about it deeply to understand what's going on, right? You just need to think about how are resources being distributed? How is happiness being distributed? So it's not going to be dollars and cents every time, but an outcome can be Pareto efficient even though it's not monetary. All right? So next week, you'll see the prisoner's dilemma for the first time. And the entire punchline of the prisoner's dilemma is that the predicted outcome is Pareto dominated by one of the other outcomes. That's the entire point of the prisoner's dilemma, is no matter how you slice it, the prediction that you generate from that model, that prediction outcome is Pareto dominated by another available outcome. And that's why it's sad. It's a sad story. The prisoner's dilemma is a sad story. And the reason it's a sad story is that we left resources on the table. Right? So that's what we're talking about when we talk about Pareto optimality. And then just to make sure that we're being completely thorough, the n player version of it would be the following. Suppose that I have a set of alternatives, X, and suppose that I have n individuals, you, Chewy, Chancellor Jones, Sang-hoon, everybody, right? So I've got a collection of individuals, n, 1, little n. Let's say I have little n individuals. That might be 2, it might be 5, it might be 350 million, who knows? Okay? And each one of those individuals has a utility function that maps the outcomes to happiness numbers. And I'll subscript them. I'm going to index those utility functions with a little I. Right? So you have a utility function, Chewy has a utility function, Chancellor Jones has a utility function, Sang-hoon has a utility function, and so on. Okay? And so the idea here is that an outcome, one of the things in X is Pareto optimal if it isn't Pareto dominated. And it's Pareto dominated if there exists some other available outcome where everybody in society is at least as well off from the second outcome as they are from the first, and at least one person is strictly better off. So you can generalize this idea of Pareto to more than two people, although it gets harder to think about the substantive justifications of that other than a social planner. And the social planner is just a really useful fable. They're all fables. Fable. All right? But the social planner is an interesting idea. What if the person that made the decisions actually was completely benevolent? There's a Homeric assumption, but it's a really useful one. So the idea of Pareto optimality is that we don't want to leave any resources on the table, right? We don't want it to be the case that, or it's sad when it's the case. Sometimes it's a fact of life, but it's nevertheless sad when we don't achieve Pareto efficient outcomes. It is sad if we can't find a way to get to that frontier where everybody is at least as happy as they could be without somebody else being made worse off. So this Pareto optimality is a really important concern. It's also the reason that, so this might sound strange to you, but the game theoretic normative pitch for why things like war are bad, we know why war is bad. People die, it's awful, just awful, right? But sort of the game theoretic angle for why war is so awful is that it's Pareto dominated by peace. You could have, for any given outcome that happened from a war, you could have made at least one party strictly happier without fighting the war if you had found the peaceful alternative, right? So these inefficiencies that arise, these Pareto inefficiencies that arise, it seems abstract, and right now I'm just talking about pennies. But what if I had said instead that we were talking about how to divvy up territory without fighting? Or what if it was two parties that were bargaining about how many resources to give across society? Right? We wouldn't want to leave resources on the table if we didn't absolutely have to. So the question becomes, what sort of processes, what sort of social processes are related to this interesting and useful seeming concept of Pareto optimality? And I think that that's why we should talk about bargaining in the B block. So let's go to the B block. So what is bargaining? You had a whole block to think about it. I told you to think about it. Did you think about it? No. I try. I'm just waiting for that Mr. Holland's Opus moment to happen. I'm just waiting for suddenly. I'm shouting in this can at you and then I'm just waiting for that moment. But it hasn't happened yet. That's fine. What's bargaining? What makes bargaining bargaining? How would you know bargaining situations when you saw them? I think that two things matter in bargaining. I think two things make bargaining bargaining. Two things make bargaining bargaining. And it's pretty simple. One. So two actors, let's talk about two people that are bargaining. You and a car dealer. Right? You and a potential employer. What makes bargaining bargaining? When you're trying to get a higher wage, or you're trying to get a better deal on your car, Or if two parties are bargaining and they're trying to figure out, how to set a policy together. What makes bargaining bargaining? Two things. One, the two parties have opposed preferences, right? So when you go to a car dealer and you buy a car, you want to save money. You want to spend as little on the car as possible while still getting the car, right? You want to spend as little on the car as possible. I'm not trying to tell you anything fancy here, right? So when people go to buy cars, they enjoy getting cars that are inexpensive. They don't want to pay more for the car than they have to. Here's the problem. Car dealers love it when cars are sold for high prices. So the car dealer that you buy the car from, they want the outcome to be one where you paid a lot for it. And you want the outcome to be one where you didn't pay a lot for it. Every dollar that you save is a dollar that the car dealer loses. And every dollar that you get overcharged is a dollar that you lost. So what makes you happy makes the car dealer sad, and what makes the car dealer happy makes you sad. It sounds an awful lot like something from the A block, doesn't it? So there's a zero-sum quality to bargaining. There's a zero-sum quality to bargaining. Bargaining outcomes are those where what makes one party happier makes the other one sadder. There are no win-wins in bargaining. Right? So that's part one. Part one. One thing that makes bargaining bargaining is that the parties have opposed preferences. Okay? Two. Both parties want to make a deal. Disagreement is costly. So, if you're bargaining with a car dealer, and the car dealer wants high prices and you want low prices, let's suppose that you failed to strike a deal. You're like, okay, fine, it's end of business, I'm done. I'm done with this. I'm going home. And the car dealer's like, fine, go home. I'm going home too. Okay, what happens? Well, the car dealer didn't sell the car, so they lost money. And you're walking home. Both of you have incentive to make a deal. You want to make a deal. Disagreement is costly. Okay? But your preferences over the outcomes that are better than that disagreement point are completely in opposition. And that's all the bargaining is. That's all the bargaining is. All the bargaining is something where you both would stand to gain. There are win-wins from the status quo. So at the status quo, there are opportunities for win-win. I can start inside of the triangle and go out to the frontier, right? So the situation where the car dealer has the car and you don't, that's inside the triangle because you would like a car and the car dealer would like to sell the car. So there are ways to make both of you happier, but then once we get to that frontier, then it's zero sum. So in other words, Pareto optimality is intimately linked to bargaining. Yeah. So that's all the bargain. We're going to talk about different bargaining processes in this class. You're going to see some examples on your problem set, but it's also going to come up when we talk about subgame this is going to come up a few times. There's even I think a lecture entitled Bargaining Revisited. We're going to look at the bargaining model of war. We're going to look at legislative bargaining. We're going to look at repeated offers bargaining. There's going to be a lot. There's a lot of bargaining. But all that makes bargaining bargaining are those two things. And they're intimately related to this Pareto optimality concern. So let's visualize what a bargaining problem looks like. All right? So a bargaining problem is like the following. You enter into the world, you and the car dealer enter into the world with a status quo utility. We can call that a disagreement point. Right? So you both enter into the world with this disagreement point. And we can just measure that disagreement point in terms of utility. Right? So how happy are you at the status quo? How happy is the car dealer at the status quo? All right? And one thing that makes bargaining bargaining is that lives inside of the triangle. Okay? So there exist outcomes, in the set of outcomes, there exist X's such that you're both happier than you were at the status quo. That disagreement point is not Pareto optimal. All right? So it's somewhere in the triangle, and where it is tells you how good everybody's bargaining power is. Part of bargaining power is being okay with disagreement, right? What makes you a strong bargainer is being able to reliably say, okay, if we don't make a deal, that's fine because I can go make a deal somewhere else. Bargaining power is about having good disagreement points, having good status quo utilities. You'll see why visually in just a moment. All right? So wherever that dot is, let's just imagine that there's a situation where you don't want a car that badly, okay? So that means that your disagreement point is actually pretty good, because if you don't make a deal, then you're perfectly happy. You're not perfectly happy, but you're pretty happy to walk home, all right? And let's suppose that the car dealer really needs to make this sale. Otherwise, the car dealership is going to close up, all right? So suppose that's the situation. Well, if that's the situation, then your disagreement point is pretty far to the east, and the car dealer's disagreement point is pretty far south. So they don't want to not make a deal, and you would be more okay with not making a deal. All right? Suppose it was vice versa. Suppose that you really needed a car. You're moving. You've decided to finally move, so you're moving, you need a car. And the car dealer, suppose that they can sell the car to whomever they want. Business has been great for the car dealership. Well, if that's the case, then your disagreement point moves way back to the west, and the car dealer's disagreement point moves north. Okay? So wherever, we can just put this dot, this D dot, this disagreement point dot, and all that tells us is how good the disagreement is for both parties. How okay would they be with not making a deal? And it's not on the frontier because they both want to make a deal. Otherwise, this wouldn't be bargaining. One thing that makes bargaining is the disagreement is costly. And that's the realization of that. The fact that the disagreement point isn't on the frontier is what I mean. Okay? So that's the disagreement point. So let's try to visualize which part of the frontier is relevant then, because if your disagreement point is anywhere east of the vertical axis, and the car dealer's disagreement point is anywhere north of the horizontal axis, right? Then not every Pareto efficient outcome is better. So let's just put that disagreement point where it is. And I just want to highlight the fact that I can find Pareto efficient outcomes that you don't want relative to your disagreement point. There are some things that are worse. There are some Pareto efficient outcomes that are east of your disagreement point. Likewise, there are some Pareto efficient outcomes that are south of the car dealer's disagreement point. So not everywhere along that frontier is entirely relevant. Okay? Note also that as I move your disagreement point more and more to the east, so that you are more and more okay. So if you get more and more okay with disagreement, then the set of relevant bargaining outcomes gets smaller and smaller and better for you. Likewise, if I move the car dealer's disagreement point up, okay, then the set of relevant bargained outcomes gets smaller and smaller and better for them. So that's what I mean. Good disagreement points yield better negotiated outcomes. You can see that visually here. So on your last problem set, you worked out the expected utility of war for two countries, right? For country A and country B. So let's just think about X is the set of all negotiated outcomes. So it's any number between 0 and 1, where X tells us how much of the territory country A has. All right? And 1 minus X tells us how much of the territory country B has. So like X is the proportion of the territory had or something, okay? And let's suppose that the countries both want more territory. And you worked out on your problem set that the expected utility of war for country 1, for country A, was P minus CA. Okay? Now, P is a number that's less than or equal to 1, and then C. So somewhere in less than 1 is that number for you. That P minus CA is smaller than 1. So that's in the interior of the triangle. And likewise for country B. Country B's expected utility for war was 1 minus P minus CB. Well, that's less than 1. Right? So we wind up with these two disagreement points that are less than 1. And I can put them in the space. Now their disagreement isn't you walk home and the car dealer doesn't sell a car. The disagreement is war. But it's still a disagreement point. Now notice also that if you're strong, if country A is strong, if P is high, then their disagreement point gets better, which means that their negotiated outcome gets better. And if P gets high, that makes country 2's negotiated outcome worse because their disagreement point is getting worse. Likewise for the costs. So in other words, countries get better negotiated outcomes in terms of their crisis bargaining if they're strong, or if they are resolved, if they have low war costs. And you can visualize that here. And so the tragedy of war in this picture, all of the carnage and all of the awfulness and all of the terrible things that happen in war are just in this triangle where you say disagreement is in the interior of the triangle and agreement is on the frontier. And there always exists negotiated agreements that both parties prefer. That's what makes bargaining bargaining. Disagreement is costly. So both countries want to make a deal, but they have opposing preferences over that. That's just bargaining. And look, it's all in the context of this Pareto efficient triangle. So in other words, if you understand this triangle, which is super simple, deceptively simple, there's a lot of nuance at work here. You might have to draw some. You might have to play around with what it looks like if you have one line versus another line. Right? It's easy when I'm just flashing these images on your screen. Get out a piece of scratch paper and just doodle. Just see about how that relevant set emerges, that set of Pareto efficient outcomes that are better for both parties than disagreement. But if you can work that out, you understand an awful lot about how utility functions work together and how multiple actors that are rational interact with one another. It's really just that simple. A lot of the nuance of what we're going to be talking about moving forward is about what the mechanism is, what the protocol is, what is the set of steps that take us from the disagreement point to one of the peaceful outcomes. All right? What is the mechanism? What is the set of norms? What is the set of actions? What are the accepted avenues for this, for bargaining? There's all sorts of different ways to bargain. All right? But the core bargaining problem remains the same no matter what. All right? And you're going to see that many of the models that we look at, but not all, have this bargaining flavor. They have this zero-sum flavor where both parties want to make a deal. And anytime you see that, draw a triangle. And I don't just mean in this class. Right? These triangles are actually a really useful way to think about these difficult and thorny bargaining situations. They're a nice way to visualize it all in one place. And you can see what happens if you adjust things just a little bit. And look, we parameterized that disagreement point. Instead of just saying disagreement was worth 2 utils, we said disagreement depends on how strong you are. Disagreement depends on your war costs. Isn't that interesting? So now we're saying I can say how your bargaining outcomes will vary as a function of things about you, how strong you are, what your costs are. These are parameters. These are the ways that we're going to say what a function is. We're going to say a utility function has this flavor. Right? We're going to be the gods of our modeling worlds by not only saying imagine that the country has rational preferences, but saying imagine they have these rational preferences. Okay? So it's all starting to come together in this beautiful triangle of bargaining. All that's left is to figure out what the mechanisms are, what the processes are, what the protocols are, and that's an awful lot, but what's the point of understanding the process if you don't know what the problem is? So today's was a pretty quick lecture. I really just want you to, these are two important concepts, Pareto optimality and bargaining, that are related to one another, and you can see them together. And it's a nice way for us to start our process of social analysis, not just single individuals who are figuring out how to maximize a utility function or an expected utility function. But instead, now we're saying to ourselves, hey, how do multiple rational actors interact with one another? And even though we haven't started to hone in on the mechanism of the actual choosing of actions, before we do that, it's so great just to say, hey, what is this space? What is the environment? And this is one environment that we oftentimes model within, is this environment of bargaining, the zero-sum world. Now, zero-sum has a very particular interpretation, especially if you look at it from the vantage point about thinking about Pareto optimality. Yeah? So this is one very standard framework that explains all sorts of different competitive, nasty, the aspects of politics that aren't so nice, the zero-sum parts. Being able to project those into a nice unified space and to have tools like what is a bargaining procedure and what is Pareto optimality, those tools will help you to understand that space. And then within that space, we can look at a variety of different processes, from legislatures to lobbying to war to civil violence to whatever. Bargaining processes emerge all the time, right? And whenever we say to ourselves, this seems like a bad outcome because it was costly relative to the status quo, that's our way of saying, hey, this was Pareto inefficient. Now, that doesn't answer all the questions. There are serious distributional concerns, and many people put egalitarianism ahead of optimality/efficiency, right? And there is no right answer on that, all right? But being able to see it in terms of how much you value efficiency versus how much you value egalitarianism will help you to better understand what you think your welfare functions ought to look like, what you think a good social planner ought to do if he or she or they ever existed. Now, they don't exist, but it's nice for you to know what it ought to look like in your mind. And this is all abstract and fast, and right now you're just saying triangles, I don't want to talk about that triangles don't seem the same to me as figuring out what my preferences are, and that's true. But looking at them long enough, waiting for your eyes to start to cross a little bit, then you suddenly start to see it not just for the math, and I know that just the math is so hard for you. I know that it's hard to see past the math. But I'm just telling you about how to buy cars or how to fight wars. I'd like to conclude with a provocative thought. There are two processes in politics that seem especially wasteful to me. And this is a personal opinion. To me, the wasteful political processes are war and lobbying. War is costly because people have to die, and it's awful, and we forego a lot of production, and we destroy a lot of the best things, and it's just bad. And we could have found an outcome that both parties preferred to it. That's the bargaining problem of war. That's the war's inefficiency puzzle. Lobbying is wasteful because if I'm a lobbyist and you're a lobbyist and we have opposing preferences on how we want legislators to vote, I can wine and dine them, and you can wine and dine them. We can spend a lot of money on fancy dinners. We can give a lot of money to their political action committee. Right? We can help them win the election. But they're only going to vote one way. And it's not like, I don't know if you know this, but here's a true statement. Legislators don't give refunds. Just imagine if you were a lobbyist and you spent all this money on a candidate, time, money, resources. You tried to buy their vote. Let's just put this completely cynically. And then they voted against you. Where did the money go? Where did the time go? Where did the resources go? They're gone. So not only do you not have them, you could have spent them on somebody else for whom they worked. So you paid opportunity costs. You could have taken that time, the money, the resources, and put it into a legislator that voted your way. So there's a waste. In war, there is waste, and it's awful carnage, human lives, salted fields, infrastructure destroyed. The stuff of war movies, the stuff of depression, the thing that we're trying to avoid. In lobbying, there's waste. It's far less tragic, right? It's the money that the lobbyist lost, the time that the lobbyist lost, the rent that got extracted. It's not as tragic, but it's just as wasteful. An interesting truism is that for war problems, we have developed this bargaining framework that enables people to see the problem quite clearly, where waste is the creator of inefficiency with respect to peaceful settlements. In lobbying, we haven't done that so much. Why? Well, in war, there's always the option of talking. If I'm country A and you're country B, and we're negotiating and we feel like we're on the eve of battle, I can still call you and say, oh wait, no, I'll concede. I'll give you what you want. Let's have peace. What does that communication look like? What are hotlines? What are red phones among lobbyists? How would they bargain with one another? Why would they believe one another's bargains? Why would they make deals that they then lived up to? It's an interesting and provocative question. Regardless of the protocol that tells us how the agents interact with one another, there's still a bargaining problem, whether there's actual bargaining happening or not. And so, I encourage you to think hard about other processes that generate this unnecessary costliness, this wastefulness, this lack of Pareto optimality. And whenever you find one, ask yourself, could we have bargained our way out of it? Thanks for watching.